This is Geometry 9.1, working on our first day of circles, specifically about the circumference. We're going to define a few terms. The first one is a circle. All points equidistant from a center point. It's all the points equidistant from a center point. So what we're looking at is if we have this center point, kind of like if we had a midpoint, it would be the point in the middle. But regardless of the direction that that segment was going, we would have all the points that are the same distance away from the center point. That is the definition of a circle. A radius is a segment from the center to edge of the circle. So we would have a circle, we would have a center, and the radius goes to the side or the edge of the circle. That would be R for radius. Radius shouldn't be anything new for you. You should have an idea what radius is. Diameter it's a segment connecting 2 points of the circle and containing the center. So another way you can define diameter is a chord that contains the center. But we haven't defined chords yet. So we'll just say that it is a segment that touches 2 sides of the circle, but it also has to touch the center. That would be a diameter. A diameter is going to be 2 radiuses. If a radius is half the circle, the distance across half the circle, then a diameter has 2 different radiuses on it. So when we talk about circumference, circumference is the distance around a circle. And we have a formula that talks about diameter times pi. That would be our formula for calculating circumference. And if diameter is 2 radiuses, you could say 2 pi r. 2r is your diameter times pi, and the order typically is 2 pi r. Now let's talk about what pi is. Most people are going to say pi is 3.14. But what is pi? What's the point of pi? Pi is the number of diameters that fit around a circle. So if we have this diameter that's all the way across the circle, if we would lay that around the edge of the circle, it would not reach all the way to the other side. That would be about as far as it would reach. Then we would extend it again. It may go to about there. Then the third time, it would come up a little bit short. And the fourth time, it would just be a fraction of the amount. So that would be 1. That would be 2. That would be 3. And this would be 0.14. 3.14. That's how many diameters fit around a circle. So we've got diameter times pi, and we have 2 pi r as our circumference. So if you know the diameter fits around every circle 3.14 times, and you can take the length of that diameter and times it by 3.14 to figure out the distance around a circle. That's why the formula works. We're going to be looking for an exact value, and listen to this carefully. An exact value includes the term pi. It's got to have the pi symbol in it. Answers are usually much nicer when it has the pi symbol in it. And then we're also going to find a rounded to the nearest hundredth. So let's come on down here to the first one. Find the circumference. Find the distance all the way around the circle. Notice what is given to us. What information has been shared. We see the radius is 8. You've got to be observant to that. So if they give us the radius and we're looking for the circumference, then we would most likely use the formula 2 pi r. Because this is a formula with radius in it. So this is going to be 2 pi times 8. And 2 times 8 is 16. So we get 16 pi. Which is approximately 16. You can hit the time symbol if you like. Here's the pi symbol on one of the graphing calculators. Second pi, 16 times pi would be 50.27 because our third number is 5 or bigger. And those would be in feet. It's a linear length. It's not an area, so it's just feet, not feet squared. Here, notice what they give us. They give us the full diameter. So you need to be observant to the given information. We know the diameter is 13. So we're going to use the formula diameter times pi. So if we know the diameter is 13, our exact answer is 13 pi. That would be considered an exact answer. Because pi requires a decimal, and a decimal is going to be rounded. Pi is a decimal that is a rounded value. It should be irrational and go on forever. So it's always a rounded value at some point. So in our calculator, we can hit 13 times pi, or we could just hit 13 pi, and you'll get your 40.84. and those would be inches. So you have your exact answer and you have your rounded answer. Now those are pretty simple because we're just using a formula and we calculate it straightforward. This next one, we are being asked for the radius. What is the radius? When the circumference is 65/98. What is the radius? So we're going to most likely use the formula 2 pi r because it has the radius in it. Now we just need to solve for r. 65/98 equals 2 pi r. You can handle this a couple different ways. You can divide by the 2, then divide by the pi. That would be just fine. Or you can divide by 2 pi. But there's a mistake that's typically done in this. It's important for you to put parentheses around that denominator. Let me show you why. Because when you come to your calculator, of course, the radius needs to be much smaller than the circumference. The circumference is a distance all the way around the circle. So there'd be 6.28 radiuses around the circle. So it needs to be divided by that much, really. So it's going to be considerably smaller. So we're taking 65/98 and dividing that, have to use parentheses, 2 pi. So an answer like 10.5, these are centimeters, is somewhat reasonable. Now notice what happens, 65.98 divided by 2 pi. This is a common mistake. If you don't use parentheses, you might get a completely different answer. And this would be an answer that's larger than the actual circumference that you're working with. That wouldn't make any sense. Now, some calculators understand what you're trying to attempt. And we have our 65/98 divided by 2 pi. And it's combining both the 2 and the pi together. So it's implying that you're dividing by parentheses 2 pi. So it's giving you the right answer. What this calculator was doing was dividing it by 2 and then timesing it by pi. So they're just using order of operations. So you just got to watch what's happening. Be sure you're making the calculator do the calculation that you're looking for. And that would be the radius. R equals 10.50. Here we have a tennis ball. We're going to have a can of tennis balls that have 3 tennis balls in it. And we're trying to figure out the circumference around each tennis ball. So here I have a rubber band around my tennis ball to represent the circumference. It's kind of like the equator of the tennis ball. So how long is that rubber band when it goes around a tennis ball? My calculation that I have is that we have 3 tennis balls all on top of each other. And when we do that, we're getting 9 inches from the top of the can to the bottom of the can. So if we have 9 inches divided up by 3 different tennis balls, that means each tennis ball is going to be 3 inches, and that's going to be your diameter. And so if the diameter is 3, we know that the circumference is diameter times pi, so that's going to be 3 pi. And we can figure out 3 pi in terms of a decimal. A rounded answer is 9.42. So I'm not convinced that a tennis ball, 3 tennis balls, reaches 9 inches, but that's the maximum that it could reach in this particular container. That's just the numbers that we're given. I feel the diameter of a tennis ball is a little bit less than 3. There's 3, so it's a little bit less. But when you're putting it into a container, it probably has a little bit extra room. But that's the calculations that we would come up with. All right, last one. This is on your test. This one gets kind of complicated. It's got different parts to it. So we're taking a track. And a track has 2 straightaways. Then, on the sides, the track has half a circle. And then on the other side, it has half a circle. So there's our track. The track has a 70 and 170 size of a rectangle. 70 by 170, that means it's 170 on this side also. The number that we don't know is the distance around half of our circle. So how are we going to find the distance around the track? We have half a circle, plus we have a straight section, so we'll just call it a length, plus we have a half a circle, you can call that a semicircle, plus we have another length. So notice the distance around a track has 4 parts to it. It has 2 curves and it has 2 straightaways. So how are we going to figure out the distance around half this circle, what we could call a semicircle? Half the circle. What numbers do we need to know to calculate the distance around a circle? And we're just going to take half of it. Having the diameter would be very helpful. And if you look at our measurement here, they give us the diameter. Would we know what the radius is? The radius would be half the diameter. So if you wanted to do your calculation using radius, you could take half of 70, which is 35, and your radius is 35. But if we're given the diameter, that's just fine. we're going to take half of 70 pi, because that's diameter times pi, but we only want half the circle. We don't want to go all the way around. Plus we have our length, which is 170. We have another half a circle on this side. Now some of you might say, well, just don't take half. You take one full circle and you have the two halves put together. Well, that's completely true. Plus we have the other length. So this is going to come out to be half of 70 pi, which is 35 pi, plus our 170, and our 35 pi, because it's half the 70. So 35 and 35 is 70 pi, and 170 and 170 looks like 340. That would be our exact answer. It's a little complicated looking like that. So we could calculate that as 70 pi plus 340. We wouldn't need to use parentheses because we're not doing any additional dividing or parts to it. We want 70 times pi, 70 pi, plus our 340. That should be the same thing as taking half of 70 pi plus our 170 plus the other half of 70 pi plus the additional 170. That's what we had up here. Should give us the same result. So we collected our like terms, and that's going to be approximately 559.91 meters. That's the distance all the way around this particular track.